Hello year 9s, how are you guys? Welcome back to Mr. Chen's videos. So today in maths, we will continue with our geometry. So today's topic is going to talk about using the scale factor to find unknown side. Okay, we will also be looking at using the proportion statement. So both scale factors and proportion statements to find unknown side of two similar figures. Okay, remember this only apply to similar figures. It doesn't apply to congruence, triangles or rectangle, etc. Because as we know, scale factors mean it is either enlarged or reduced. So if it is congruent figures, the scale factor is going to be 1. There's no difference between the two, okay? So let's begin. The keywords that you need to know is unknown side. Second is matching side. Third one is the scale factor. Fourth one is large shape, small shape, and proportion statement, okay? So these are the keywords that we will be using over and over again for these videos. So let's begin. Using the scale factor to find unknown side. If we know two figures are similar, so similar means for those who don't know, similar figures have the same angle, okay, but have different length. The length are usually in proportion, as in like it can be twice as big or half as big as the original one. Okay, that's what similar figures means. So if we know two figures are similar, we can calculate the scale factor from the known side length, then use the scale factor to find missing side length. Okay, so we kind of take advantage of the proportions to find the unknown side if we don't know what it is. So the scale factors, like I said from the previous videos, is k equal to length of side of large shape or divided by length of matching side of the smaller shape. So always start with the matching side of the large one, divide by the small one. Okay. So if you rearrange proportion, the formula, you will realize that the length of the side of the large shape, okay, is actually length of matching side of small shape times k. Okay, what you do, how did I find that out? All you need to do is this, so k equal to length of side of large shape divided by length of matching side of small shape. Okay, so how do I get to this one? It's actually quite simple. We are trying to find unknown. So let's say the unknown one is if we want to find unknown for the large. So if one of the large length of unknown, the length of the side of large shape, one of them is not given, then all you need to do is move that across, move this one length of matching side across, which means because it's initially is divided, to get rid of divided you multiply. Okay, so it becomes k multiplied by length of matching side of small shape, which will equal to your length of side of large shape. which is, if you look at it, is exactly the same as that. On the other hand, if you try to figure out the matching side, the unknown length of the matching side of the small shape, you have to divide it by the k. Divide the length of the side by k, okay? You will know what it means when I start doing it. So let's begin. So over here we have a rectangle, two similar rectangle, okay? And the height is 12, on the small one is 12 centimeters. The height on the larger one is 18 centimeters. And the length is, one is 40 but the other one is unknown. Okay, so we can actually find out what that x is by using the scale factor to do it. So first you have to actually find the scale factor first. We can actually find the scale factor since we know they are similar triangle. I mean not triangle, rectangle. So one is 12, one is 18. As we know, the k is the length of the large, okay, divided by length of the matching side of the small shape. So the length of the large is 18 centimeters. Length of the small matching small shape is 12. So that will give you 1.5. Okay, if you divide it, that means the large rectangle is actually 1.5 times bigger. Okay, so from there we want to find out what x is. So we know the length of the rectangle small one is 40 centimeters. Okay, and we don't know what the x is of the large one. So using that formulas right here, we want to use this one, length of the side of the large shape. Okay, unknown. I will actually write it down here so that we actually have more space. So length of side of large shape, okay, which is x, okay, equal to length of the matching side of the small shape, that is 1.5, okay, times sorry, is 40 centimeters, and times the k. K is your scale factor. Scale factor here is 1.5. So when you multiply that, that will give you 60 centimeters. So we know that one is going to be 60 centimeters. That is how you use that to your advantage. Okay, remember, you need to remember that scale factor formulas, and also which one to use, whether you are looking for the unknown of the bigger shape or unknown for the smaller shape. Please, I'm gonna go through one more example on the next one, and then I'm gonna teach you how to use the proportion statement as well. It's very similar. So on the next page we have, don't worry about that proportion side yet. Don't worry about that for now. Okay, so we're gonna come back to that. I want you to actually look at the two quadrilaterals. Two quadrilaterals are similar, and we can see on the small one, there is an unknown a, okay, that you need to solve. But on the large quadrilateral, we have both values. So first we have to find the scale factor. So the scale factor is this, okay? The length want the length of the larger shape, which is 6. Okay, because you need to have both, you need to know both of the same matching one in order to figure out the scale factor, right? So we know the large factors there is 6, and the other one of the equivalent matching side is by the small, so it has to go to the bottom, has to be divided by 4 meters. So when we do that, sorry guys, I'm a bit sick. When we divide that, which will give you 6 divided by 4, it should give you 1.5. Okay, so again it is 1. It tells you that the big quadrilateral is actually 1.5 times bigger than the small one. So what we are trying to find right now is to find out the length of the unknown length. We were trying to find out the length of the matching small shape, which is x equal to, which is your x, okay, equal to the length of the large shape divided by 1.5. Okay, the k, because since it is bigger, we have to divide it by the scale factor to find out the original one. The number cannot go bigger than 7.5 for the small quadrilateral, okay, just from logic, common sense. So if that helps, so what happens is it will be 7.5 because we want to use the matching side, okay, the 7.5, it should be meters there. Okay, 7 meters. 7.5 meters divided by 1.5. 1.5 times. Okay, there is a scale factor. It has no unit. Remember, it is just how much bigger, which will give you 5 meters. So that tells me your A here is equal to 5 meters. Okay, so depends on the situation. If you're looking for the small one, you have to divide it by the scale factor. Okay, but on the other hand, if you're looking for the length of the larger one, you have to multiply the scale factors. Okay, so the number is going to be bigger. So let's quickly move on to proportions. So in proportion, we have a proportion of the equation so that the two ratios are equal. And if we have two similar rectangles, remember the proportion statement only works on rectangle. So on rectangle, the length, the height of a rectangle B divided by height of a rectangle A equal to the width of the rectangle B over width of the rectangle A. So it doesn't matter which way you go, where you're gonna pick A or B, it shouldn't matter. So in this case, I'm gonna just make it easy. A is the B for that one. So length is this one. Okay, length, I'm gonna use blue, so length is blue. Okay, that's the length. So width is going to, I'm gonna use green for width. Okay, there you go. So what's the proportion statement? The proportion statement is height of the rectangle A, height of rectangle B over height of rectangle A equal to width of rectangle B over width of rectangle A. So height here for rectangle B is 18 centimeters, and height of the rectangle A is 12 centimeters, equal to the width of rectangle B, which is width is x, we don't know what it is, and width for the A is 40 centimeters. So that's how you write them. Okay, normally if you know what x is, you can actually replace that with a number. Let's say you can make it like 15, whatever, if it is a 15. But in this case, we don't know what it is, so we're gonna have to proceed to the question 2, which solve to find x. So to do that, what happened is you know 18 centimeters over 12 centimeters equal to x divided by 40 centimeters. So from there you need to use your algebra. So divided by 40, we'll write it one more time. So this is divided by 40. To get rid of divided by 40, what would you do? What's the opposite of divided by 40? You multiply it by 40. Okay, centimeters. So if you do that, you will get rid of it already. But if you do that, you have to do it on both sides. That means you have to multiply that by 40 on here as well. So what that means would be x would be 18 centimeters divided by 12 centimeters times 40 centimeters. Okay, so according to that math, what I need to do right now is 18 divided by 12 times 40. It's very straightforward there. Divided by 12 times 40, which will give me 60 centimeters. So that tells me x is 60 centimeters. X here becomes 60 centimeters. Okay, that is how you find them out. Technically, you can actually just use the scale factor to solve for x, but with proportion statement, you will never go wrong with that. So to conclude these videos, we went through what is scale factors and what is proportion statements and how to use them to solve for unknown side. Okay, most of the time can be x, can be a, b, c, whatever. It shouldn't matter. So please write down the formulas and write down the notes and ask me any question during our next lesson. Thank you so much, guys. Peace out. Have a good one.